Hi, boys and girls. All right, so today we're going to be starting our lesson 15, session 1. I want you to go ahead and turn to page 309 in your brand new books, and we're going to go ahead and get started. So today we're going to start talking about multiplying a decimal by a whole number. We've worked with that multiplying before, and we've worked with decimals. We just never worked with both at the same time. So here we go. It says, you know how to multiply two whole numbers. Now you will learn how to multiply a decimal by a whole number. So we're going to use what we know to solve this problem. All right, so Margot has 6 square tiles of equal size. Each side of each tile is 0.8 inches long. So when I do this, I usually go 0.8, and then this side is 0.82 because they're squares. Okay. Margot places all the tiles in a row, with sides touching as shown. How long is the row of tiles? So we're looking for the length. All right, so in order to find the length, we have 0.8 times 1, 2, 3, 4, 5, 6. We have 0.8 times 6. That is our problem. 0.8. That looks like a B. Hang on, let me move my big head. I can do this. Okay. 0.8 times 6. 6 wholes times 0.8. So one way you could do this is you could add up 6.8. So if I did 0.8, pretend that's an 8, plus 0.8, I would get 1.6, because I know 8 plus 8 is 16, but that 1 needs to carry over into the next place value, so it goes into the 1. Then I have 1.6 plus 0.8, so this is my third 0.8, and that would give me, so 8 plus 6 is 14, and then one more would carry over here, so it's 2.4. All right, and then if I took 2.4 and I added 8.8 more, I have to think 8 plus 4, 9, 10, 11, 12. So the 2 would be in the tens place, and that 1 more carries over to the ones place. So it's 3.2. I've got 1, 2, 3, 4.8. I need to do another one. 3.2 plus 0.8. That gives me 4 wholes. And then I can do another one. 1, 2, 3, 4, 5. One more. So 4 plus 0.8 equals 4.8. I'm going to check and make sure I've got 6, because I'm supposed to do this 6 times. 1, 2, 3, 4, 5, 6. My answer is 4.8. Another, and I believe quite easily to be an easier way, is you take the 6 wholes and you multiply it by 0.8. All right, are you ready? 6 times 8 is 48. Oh, just kidding. I'll do it this way. We'll get there, I promise, but that's not it. All right, so 6 wholes times, now you guys know how this is 8/10, so I'm going to write that as 8 over 10. So 6 times 8 over 10, 6 wholes is really, if I write that in fraction, 6 over 1, and then I multiply straight across. So 48 divided by 10, and we all know when we're dividing things by 10, that we can move our decimal over one place value to the left, or we can think to ourselves, well, 10 goes into 48. Ready? 4 whole times. There's 8 left over 10. This is telling me that in decimal form is 8/10. So I know I write 4 wholes like this on this side of the decimal, and 8/10. The 8 goes in the tenths place. So 4.8. I think that this way is easier rather than adding. But we'll see what you guys think. All right, moving on. It says, explain how you found the length of the row of tiles. So what I did was, I know that there are 6 tiles that are each 0.8, is it inches? Inches long. So I multiplied 6 times 0.8. Okay. So moving forward, it says, look ahead. You can find the length of the row of tiles through repeated addition or multiplication of a decimal by a whole number. Look for patterns in the factors and products when multiplying with the whole numbers and decimals shown below. Use the models to write the products. So for example, if I have 2 sets of 3, I have, here's one set of 3, here's the next set of 3. If I add those together, which is 2 times 3, I get 6. Okay, in this problem, it's showing me 2 sets of 3/10. Here's one set of 3/10. Here's the next set of 3/10. In total, I've got 6 total tenths. And they're doing the same thing with the hundredths over here. So 2 times 3/100. I've got one set of 3/100 and I've got another set of 3/100. And in total, I have 6/100. All right, I'm sure you've seen a pattern here. It says, what patterns do you see in the factors and products in the equations? How are these patterns reflected in the models? So what we're going to write here is that we're seeing that the value of 6, let me put this up here, hang on. The value of 6 in the product, and remember boys and girls, product is the answer to a multiplication problem. And in the models, changes from first it was 6 ones because we've got 6 ones when we've got whole numbers. Then it goes to 6/100. But that's when the factor multiplied by 2 changes from 3 ones to 3/10. So it's just saying that as your decimal got smaller, this went into tenths, your answer went into tenths as well. This went into 100ths, so your answer went into 100ths as well. And it just wants you to see that pattern. Okay, so finally down here, we're going to do a couple real quick notes. So if you guys remember correctly, partial products are where we kind of like add up in order to multiply. So what we're going to write here is we're going to write a strategy used to multiply multi-digit numbers the products you get in each step are called partial products. Now, if you need some time to write that down, go ahead and pause your video. Otherwise, I'm going to go ahead and move you to an example. So this first example, and I'm going to try to keep this as orderly as possible, is if I were to have 120, you know what? Just kidding, I'm going to type it. If I were to have 123, and I'm multiplying that by 4. Okay, so if I'm multiplying this by 4, it's basically saying that I have 4 times 3, which that would give me 12. So my first partial product is 12. My next partial product is 4 1s times 2 10s. So that would be like the same thing as 4 times 20. So that's 80. Oops. My next one would be 80. And then my final partial product would be 4 times 100 because I have a 1 in the hundreds place. So then that would give me 400. And then I can find my answer by adding those partial products up. So 400 plus 80 is 480 plus 12 more would be 492. So those are what partial products are. And I'm going to put PP for partial products. Then I've got, what does a product mean? And a product is actually pretty easy, you guys. Ready? The answer to a multiplication problem. So if I were to have 5 times 0.1, 0.5 would be my product. It's my answer because I'm using multiplication here. Now a factor is just a number that is multiplied. So what that means is that if I were to have 7 times 0.01, this is a factor and this is a factor. Oops. Factor. And this up here is my product, and these are factors. So product, factors. This would give me, because this is hundredths place, and I'm multiplying it by 7, it would be 7 hundredths. All right, boys and girls, so you guys are going to, it says look at the multiplication below. What are the factors, partial products, and products? So using this information on the top, tell me using which numbers are what. Number 2, it just wants you to go, or 3, it wants you to go ahead and solve the problem. And with 4, it says check your answer. So if you're just multiplying using the way that we did up here, then a good way to show, check your answer is by doing the repeated addition. So make sure that your way of doing this is different than your way of doing this, so we know that you're getting the right answer. And that is all I have for you today.